In this tutorial, I'm going to quickly go over quiz number 4, which I'll give you tomorrow. The first thing I'm going to test here is the constant acceleration between, I don't know, between x and y direction. So let's say you have x direction. This is x direction, of course, is visible, and this x direction is, let's say, 20 meter, right? And this is y direction, of course, this is also visible, and let's say this is also 20 meter, right? And the person A, let's say person A, uh, moves, spends, I don't know, it takes 2 seconds for person A, 2 seconds for person A to move from location A to B, right? With constant velocity. And person B, let's say person B, on the other hand, this is person B. Person B starts with initial velocity 0, and he accelerate 5 meter per second square. As a result, he lost control at location B, and he ended up at location C. So what is the person? What is person B's? This is person B. What is person B's velocity at location C? Now let's find the person A's velocity at location B. Person A is the blue. Velocity over here for person A, for this person, it would be very simple. Velocity is distance over time. Since he's moving with constant velocity, his velocity from A to B remain the same. So 20 divided by 2, 10 meter per second. All right, we can grab this. Okay, we can grab the person A's velocity right here. So 1, 2, 3, 4, 5, 6. This is for person A at the x direction. This is dt. This is displacement versus time. This is st. This is velocity versus time. This is acceleration versus time. This is what? Acceleration versus time. This is, of course, person A, so we're going to use blue. And his velocity remains same for 2 seconds, right? What does that mean? His velocity remained 10 meter per second for entire 2 seconds. What does that mean? His acceleration is 0 for person A, right? What does that mean? If this one is horizontal, this one must be diagonal. So this must be 10t. For how long? 2 seconds. And how much distance did he move? Of course, 20 meters, right? So, right. So, 10t. Okay. So, and then this is going to be the same also, 10t. Why is that? Because it's moving to the positive direction, and the direction, never forget, this is east, this is west, this is north, this is south. Since he's moving east, everything, all 6 graph would be same. But on the other hand, the person B, 1, 2, 3, 4, 5, 6, this is distance time, this is displacement time, this is speed time, this is velocity time, this is acceleration time, this is acceleration time. For person B, I did use rate. For person B, so we use rate. Distance is parabolic for 2 seconds. Displacement is also parabolic. Speed is then diagonal. Velocity is then diagonal. Acceleration is this, and acceleration is this. Of course, he was moving 5 meter per second square. Okay, good. Okay, so this is at the x direction. Okay, now we're gonna focus on y direction. Person B was moving at the y direction is because he lost control over here. Pay attention over here. Person B's y velocity over here at the edge of the building, velocity at the x direction and velocity at the y direction. Velocity at the x direction is way bigger than 0, but velocity at the y direction is 0. And we care about only velocity at the y direction. Why is that? Because x direction has nothing to do with the time it takes to land the ground, right? X direction only increases the range. Okay, if you increase the velocity at the X direction, that increases the range. Okay, this is X, this is 2x. Okay, this is X because if velocity X, for example, is 5 meters per second, this is 2x is because the velocity of the X direction is 10 meters per second. So if you increase the velocity of the X direction, it increases the only range. It does not increase the time. So we are talking about the time. Speaking of time, now let's find the time. How long Mr. Person B was in the air. So D is equal to VAT plus half AT square. Of course, everything at the y direction, right? So this is a negative, I don't know, negative 20. Negative 20. This is 0. And this is half negative 10. And this is t squared. So this is 5. And then we cancel 4, so t is equal to 2 seconds. So the person was falling for 2 seconds when he hit the ground at 2 seconds. All right, so that means vf is equal to vi plus at, again at the y direction, right? So his vf is equal to his vy, of course, is 0, and this is negative t is 2 seconds. So how, yeah, his velocity when he collide with the ground is how much? Negative 20 meter per second. Now we should be able to do 6 graph, of course. You always draw graph. 1, 2, 3, 4, 5, 6. Of course, you're going to call them dt, displacement versus time, st, velocity versus time, acceleration versus time, at, right? And then you draw that. What are you going to draw? This one. Displacement versus time is, of course, is falling, right? Yeah. Okay, so the velocity versus time, falling for how long? 2. And what is her final velocity? Negative 20. Falling for how long? 2. And what is his final distance? Final distance is negative 20. And this is absolute value of this one is this 2, and this is 20. Absolute value of this one is this is 2, this is 20. um, Absolute value of this one is this, and absolute value of this one is this. Okay, so this is for person B. Person A did not fall. Person A was able to stop there at the edge of the building. Now the second part of the quiz is projectile motion. And as you know that projectile motion creates parabola. So projectile motion. So projectile motion creates parabola. All right. So there are 3 projectile motions we're going to be talking about today. So number 1 is, of course, dropping. Number 2 is throwing up. And number 3 is throwing down. Okay. When you drop something, by definition, velocity is 0. When you're throwing up something, can you throw up anything with initial velocity 0? Well, no. Initial velocity has to be positive, otherwise you cannot throw up anything. Can you throw down anything with initial velocity 0? No. Can you throw down something with initial velocity positive? No. Initial velocity has to be negative for you to throw down. So throw down is negative. Okay, good. So let's pause, go over dropping. Okay, so let's drop something from 20 meter above the ground. Okay, you're dropping something from 20 meter above the ground, and we are trying to find everything. What we are trying to find? We are trying to find uh, the initial velocity, time, uh, displacement, distance, velocity, speed, and acceleration due to gravity at 3 locations. Okay, so we're gonna draw the graph as well. 1, 2, 3, 4, 5, 6. dt, displacement versus time, st, velocity versus time, acceleration versus time, and at. Okay, good. So okay, good. So velocity initial is 0. All right, at 1 second, uh, at 1 second velocity initial is 0. Oh, at let's just start with 0 second. At 0 second, everything is 0 actually, except this one. In fact, acceleration due to gravity is always -10, no matter what. Okay, so we want to find out x. What does that mean? How long the object was in the air? T is equal to VAT plus half AT squared. How long? It is -20. So VI is 0. So 0 minus 10, well, 10 divided by 2 is 5T squared. So 4. So T is 2. Okay. So T is 2. So total trip was 2 meter long. All right. Total trip is 2 meter long. 2, 2, 2, 2, 2, 2. Okay, good. And acceleration is, of course, -10. And this is 10. Now we're going to find the other information. We want to find at 1 second what would be the distance and displacement and so on. So t is equal to VAT plus half AT square, right? This is 0. So at 1, half -10 and 1 is square, and that is -5. Displacement is -5, distance is 5, and velocity would be what? At 1, VF is equal to VI plus AT. So VF is equal to VI is 0 minus 10 at 1. So VF is at 1 second, VF is -10 and speed is 10. So we know almost everything. Uh, okay, and we want to know now at 2 second what is the speed, at 2 second what is the velocity. Okay, so at 2 second what is the distance? T is equal to VIT plus half AT square. At 2 second this is 0. At 2 second, half -10 and 2 square is 4. This is 5 times 4 is -20. So this is 20. And velocity would be VF is equal to VI plus AT at 2 second. This one would be -20, right? So -20 and this one would be 20. So now we're going to finish the graph. What is it? This is 20. This is -20. Okay. And then this one would be -20, and this one would be 20. Okay, so we finished the dropping, right? Okay, so what next is throwing up. What are we gonna do? We're gonna throw up something. Let's do throw up. Okay, so this is your position and this is your, I don't know, time. Okay, so you throw up something in the air with 90 degree, right? You throw up something in the air with 90 degree. Let's see what time it is. It's 1:41. Right. Okay. So let's say you throw something up in the air with velocity -20 meters per second, right? If you do that, what is your final velocity? Your final velocity must be uh, I'm sorry, throwing up. So velocity initial uh, uh, must be um, must be positive. So 20 meters per second. So velocity final then -20 meters per second. But before I give you this information, let's find loss of thing. Let's create those boxes. So initial velocity, time, displacement, distance, velocity, speed, acceleration due to gravity, at 0 second, at I don't know, you're gonna find this out. But we know one thing: at 0 second, initial velocity is not 0. Initial velocity is 20. Displacement is 0. Everything is 0 except this one. Okay, so we're gonna draw 6 graph as usual. So 1, 2, 3, 4, 5, 6. This is dt. This is displacement versus time. This is st, this is velocity versus time, at, this is acceleration versus time. Excellent, good. Now, how long the ball was in the air? Okay, we know a few facts. At right here, okay, velocity is 0. We can use this information, but more importantly, we can use this information. Bf is negative 20. So by using this information, Bf is negative 20, we can find the Tf. Right? Uh, by plugging in Bf, we can find Tf. Well, how's that? Vi is 20 minus 10t, right? So negative 40 is equal to negative 10t. So t is 4. So, okay, so the object was in the air for 4 seconds. Okay, that's a long time object was in the air. That means what is the time over here at the max height? Not 0 at the max height is 2 seconds because 4 divided by 2 is 2. Okay, we know few things. Negative 10, negative 10. We know this one, right? At 2 second, what is going on? At 2 second, velocity must be 0 because velocity is 0 at the max height. The speed is also 0. Okay, what else going on? This is 20, this is 20, and the displacement, final displacement is 0, right? And final distance is not 0. Final velocity, we're gonna find the final velocity, which is 20. Final speed is 20. Okay, so it seems like we need to only find 3 information, which is super easy. Displacement at 2 seconds, so d is equal to vat plus half at squared, and that is displacement. Vi is 20 and t is 2 minus 10 4. uh, 2 squared is 4. So displacement is 40. Hold on. Displacement at 2 seconds. So okay. So plus minus half. Uh, okay, plus half negative 10, and this is 2 squared. So what do you get? 40, and then this is 5, and then 5 times negative 5 times 4, 20. So displacement is 20. So displacement is 20. What does that mean? From here to here, from here to here is 20 meter. Okay, so then this is also 20 meter, and this is displacement is 0, so this must be displacement 40. Okay, we finish it. Now we're gonna finish the graph. The displacement versus time graph would look like this. The velocity versus time graph would look like this. This is 4 seconds, so this must be negative 20. This must be positive 20. This must be 20. This must be negative 20. So total displacement is 0. Acceleration is negative, which is 10, and distance is slowing down from here to here, so it's slowing down, and it's speeding up from here to here, so this is speeding up. So total distance is 40 for 4 seconds, and its speed is maximum speed is 15, and slowing down to 0 and 15 again. All right, so if you add this one and if you add this one, what do you get? For 4 seconds you get 40 meters, and you get 0 meter. All right, these are the 6 graphs for object throwing up. Now we're going to do throwing down, and that would be the last one, of course. So now you have an object is um, 20 meter, right? 20 meter, uh, and you are throwing down an object, right? And how long does it take? The first one, it took 2 seconds. Let's see how long it. This one, it took 2 seconds. When you when you drop something, it took 2 seconds. Now this one is going to take less than 2 seconds. Okay, why is that? Because of course you're throwing it down. So again, this is velocity initial. You're throwing it down with how much? Initial velocity. Let's say you throw off with how much? let's see, 0, and then throwing it down by less than negative 40, negative 4, 4 meter per second. Okay, so initial velocity, time, displacement, distance, velocity, speed, and acceleration due to gravity at 0 second. Okay, we can start always at 0 second, right? And that's a good starting point. At 0 second, this is negative 4. It's negative 4 anytime, and this is negative 10, negative 10, negative 10. Okay, so we know this for sure. Okay, so the time, final time. So how can we know the final time? The final time is so Vf is equal to Vi plus At. By plugging in, we want to know the final velocity. By final velocity would be, no, this one not going to be able to give us. So D is equal to Vat plus half At squared, 10 T squared, all right? Plus 40 minus 20 is equal to 0. So minus b plus minus b squared minus 4ac over 2a. All right, so b is minus 4 plus minus 16 minus 4, a is 5, and c is negative 20, and this is 2a, so 10. So minus 4 plus minus 416 over 10, or plus minus 20.34 divided by 10. So minus minus, we're not going to, so minus 4 plus 20.34 divided by 10, 1.64. So the time is 1.64, which is less than 2, by the way. So which is less than 2? 1.64 is less than 2. So let's do 1.64. So this is 1.64. 1.64, and this is 1. Okay, at 1, what is the distance? But let's first finish the first one. 0, 0, 0, or 0, negative 4, and this is 4. Let's see whether I made any mistake over the other one. This is not 0, by the way, this is 20, the first one. Okay, so negative 4, at 1 second, what is the displacement? D is equal to Vat plus half At squared. What does that mean? D is equal to Va is negative 4 at 1 minus 5 square. So D is equal to minus 4 minus 5, so minus 9. This is 9. Velocity is Vf is equal to Vi plus At. So Vf is equal to Vi is how much? Minus 4 minus 10, 1. So Vf is equal to negative 14. Negative 14. This is 14. Okay. So 1.64. You can do it now. So this the same way. So this is the quiz tomorrow.